So in this video, we're going to talk about the natural exponential function, okay, which is f of x equals e to the x and the number e, okay? And I'm going to show you how the number e is derived and help you understand that the number e is a lot like the number pi, okay? It's an irrational number. They've calculated it out to like trillion places after the decimal, and it keeps going, okay? So it's one of those irrational numbers. It never terminates, it never repeats, all right? And the number e we're going to use for exponential functions, okay? And eventually logarithmic functions once we get into that, all right? So the number e, any positive number can be the base of an exponential function. And we're going to work with the numbers 2 and 10 a lot as a base, okay? But we're going to use the letter e, the number e here for, the base of exponential functions as well, okay? So the number e is defined in several different ways, but one of the easiest ways that we're going to use it, and one of the most applicable ways in terms of everyday life, is through this expression right here. So 1 plus 1 over n to the nth power, okay? And we use that in what we call compounded interest, which happens every day in the banking system worldwide, okay? So I'm going to show you this table. And basically this table just takes these n values and plugs them into this expression. And what you see as you plug in larger and larger numbers, the value for this expression gets closer and closer and closer to what we call the number e, okay? So just plugging in 1 million into n here and here and evaluating that, we're able to get e to 5 places, so 2.71828, okay? And obviously, again, if you were to plug in 10 million, we would get closer to e. If you were to plug in 1 billion, we would get even closer to e, and so on down the line, okay? But basically, you can estimate the number e to about 2.71828, okay? And taking things out 5 places is a really good, this is a really good representation of the number e, okay? Now, most functions we're going to use in terms of applications for this, we're going to use e, and when we get into logarithms again, we're going to use what's called the natural log, which has a base of e, okay? But first off, let's talk about the natural exponential function, which is f of x equals e to the x, okay? It's also referred to as the exponential function, okay? So in order to evaluate that, e to the 3, you can actually plug in 3 into this, okay? Or you can use a calculator, all right? So if we use Desmos Scientific Calculator, you're going to find e under function here. Okay, so e to the x, and that's going to be on your Texas Instruments calculators as well. On your smartphones, you're going to see e to the x when you turn your phone sideways, etc. So we want to do e to the x, and we want to do it to the 3rd power. And you can see that equals 20.0855, so on. Okay, so we go here, and you see that value. Okay, 20.08554. Okay, I'm going to skip over B for a second and go on to C because it looks the most like A. All right, so let's plug in 4.8 here. So let's get back up here to the exponent. So we do 4.8. So e to the 4.8, again, you need to think about this. It's just a little bit less than 3, okay? 3 to the 5th power would be, a relatively large number, okay? But e to the 4.8 would be about 121.51, okay? And you can see here, we get that 121.51 number, okay? You can already see what 2 times e to the negative 0.53 is. It's going to be this value. But let's just go ahead and plug that into the calculator. We've got 2 times e to the negative 0. And let's make that a 5.3, okay? So you can see that's 1.17721, okay? So using a calculator makes this a lot easier. And you see we got that same value there, okay? So that's how you use a calculator to evaluate e to any power.